Q8384. The primary purpose of high-lift devices is to increase the A. L/D max. B. Lift at low speeds. C. Drag and reduce airspeed. The correct answer is B. The primary purpose of high-lift devices is to increase the lift generated by the wings at low speeds. High-lift devices, such as flaps, slats, and leading-edge devices, modify the shape and characteristics of the wings to enhance lift production during takeoff, landing, and other low-speed flight conditions. By increasing lift, these devices enable the aircraft to fly at lower airspeeds, which is crucial for safe takeoffs and landings. They effectively change the wing's geometry to increase the surface area, alter the camber, or modify the flow patterns over the wing, resulting in higher lift coefficients at lower speeds. Increasing lift at low speeds enhances the aircraft's ability to operate in restricted or short runway environments and improves its maneuverability during critical flight phases. Q8331, which is a purpose of leading-edge flaps. A. Increase the camber of the wing. B. Reduce lift without increasing airspeed. C. Direct airflow over the top of the wing at high angles of attack. The correct answer is A. Leading-edge flaps, also known as Kruger flaps or Kruger devices, are a type of high-lift device that extends from the leading edge of the wing. Their primary purpose is to increase the camber or curvature of the wing when deployed. By extending the leading edge downward, leading-edge flaps increase the curvature of the wing's upper surface, which in turn increases the camber. This change in camber helps to generate more lift at lower airspeeds, particularly during takeoff and landing. By increasing the camber, leading-edge flaps enhance the wing's ability to produce lift and improve the overall performance of the aircraft at low speeds. Q8385. What is the primary function of the leading-edge flaps in landing configuration during the flare before touchdown? A. Prevent flow separation. B. Decrease rate of sink. C. Increase profile drag. The correct answer is A. The primary function of leading-edge flaps in the landing configuration during the flare before touchdown is to prevent flow separation. During the landing phase, as the aircraft approaches the runway, the angle of attack increases to generate more lift at slower speeds. However, at higher angles of attack, there is an increased risk of flow separation, where the airflow over the wing detaches from the surface and disrupts the lift production. Leading-edge flaps, when deployed, modify the shape and characteristics of the wing's leading edge. They create a rounded or drooped profile that helps to delay flow separation and maintain attached airflow over the wing at higher angles of attack. By preventing flow separation, leading-edge flaps ensure that the wing continues to produce sufficient lift, even at the slower speeds encountered during the landing flare. So, the primary function of leading-edge flaps in the landing configuration is to prevent flow separation and maintain attached airflow over the wing, which is crucial for maintaining lift and achieving a safe landing. Q8334. What effect does extending leading-edge slats have on an airplane's wing? A. Increases the pitch-up moment of an airfoil. B. Increases the camber and CLMAX. C. Allows for earlier airflow separation. The correct answer is B. When leading-edge slats are extended on an airplane's wing, it increases the camber and lift of the airfoil. Leading-edge slats are movable surfaces located on the leading edge of the wing, typically near the wing root. When extended, they change the shape of the wing's leading edge, increasing its curvature or camber. By increasing the camber, leading-edge slats enhance the lift-producing capabilities of the wing. This is particularly beneficial at lower speeds and higher angles of attack, such as during takeoff and landing. The increased camber helps to generate more lift, allowing the aircraft to maintain flight at slower speeds or operate at steeper angles of attack. So, extending leading-edge slats has the effect of increasing the camber and lift of an airplane's wing, improving its low-speed performance. Q8386. What effect does the leading-edge slot in the wing have on performance? A. Decreases profile drag. B. Changes the stalling angle of attack to a higher angle. C. Decelerates the upper surface boundary layer air. The correct answer is B. The leading-edge slot in the wing has the effect of changing the stalling angle of attack to a higher angle. A leading-edge slot is a type of high-lift device that creates a gap or slot on the wing's leading edge. When the slot is open, it allows airflow to pass from the lower surface to the upper surface of the wing. By allowing this airflow passage, the leading-edge slot energizes the boundary layer on the upper surface of the wing, delaying flow separation and reducing the stalling tendency. This means that the wing can operate at higher angles of attack before experiencing a stall. The higher stalling angle of attack provides the aircraft with a greater margin of safety, as it allows for a higher angle of attack without the risk of an immediate stall. So, the primary effect of a leading-edge slot in the wing is to change the stalling angle of attack to a higher angle, improving the wing's stalling characteristics and enhancing the aircraft's performance and safety.